Oh, bro. Or also, Armel, that Oh no, I did talk to you that the PCB course is really good.
Oh, thanks. I had nothing to really do with it, I'll be honest. I just told them to make a course about PCBs, and they did.
I think we should have more of those for our Hyperloop members, especially I think stuff like CAD too, within that kind of realm that would help us design digitally
Mhm.
in an online environment. Because
CFD will be interesting as well, or CFD and like solids, like ANSYS.
Yeah. We could probably figure out like just internal workshops where we record just like small tutorials about things, and then we can leave them for like the newer members and to go through whenever they join and pick up the skills. Okay. Maybe Dave forgot about the meeting. Is anyone from software here?
Yeah, Javad and I are here.
Yes, me and Arnav are here.
All right, cool.
All right, you can stand in for Dave. Anyway,
Yeah,
the
you are now
first
the temporary
he's here.
lead.
interim.
Yeah.
I think he's here.
So I guess to quick intro, the first bit of this is only going to cover, we're just going to give a little bit of announcement. I don't know if you guys have read. Good news that we made it past that first stage of European Hyperloop Week. So we're on our way along with 24 other teams. I don't know how many people submitted, but that's pretty cool. And now we have to submit FDD and a couple other things, but at least we got through that first stage of being accepted into the showcase. And this first bit will just kind of cover, I'm just going to show you guys what our all electrical teams are going to, the timeline we're going to follow, and the timeline that we should stick to. And this was developed by all the electrical leads so that, you know, we can get our deliverables out on time and also provide you guys with enough time dedicated so you can be able to focus on your midterms and your exams and your studies and still contribute to Hyperloop team.
Kiki, do you want to share your screen?
Yeah, sorry, I'm just pulling it up. It's just taking a
Oh.
while.
Yeah.
But basically, yeah, so I know some of you guys probably seen this a lot of times. We're just going to stress it again. I don't know if you've noticed, I've already moved this little arrow. It was here in the middle, and now it's like a lot closer to the end of January. We are coming into the end of January, and we are starting to approach our first deliverable. Actually, the first main deadline that we have for the team, and all of you keep this in mind. You need to have full testing procedures outlined for whatever system you're designing or PCB you're making. Whatever it is that needs to be tested as part of the subsystem, you need to have testing procedures made for those. And 80% of your full design document, or I'm sorry, final demonstration document needs to be completed. More details about what is required in the FDD, you can find it here and also in the actual EHW document. If you need access to that, you can contact one of us, one of the leads. We'll give you the PDF of it. But I think it's also been posted by Juan in the general chat. Otherwise, I think for you can go to Energy Systems homepage. I should have also linked it there. And this document is due in mid-March. And one of the main things it does require is a fully outlined testing procedure. And this is the reason why the deadline for the February 13th is a full testing procedure. Now, why did we choose February 13th? This is so that you guys, you know, can take reading week to relax. Don't think of reading week as, oh, I'll get my work during then. No, we want you guys to sort of like get it done by the 13th, and think of that as like a hard deadline so that you're gonna have midterms and stuff coming around after that you're gonna be worried and focused on. There's a bunch of other stuff that'll come after, but this is the main time. And actually, any parts that you need to order for your designs, they need to be ordered and in our hands by the beginning of March. That's what this part is here. That's what this is for. So that we have enough time to, put everything together, make sure we have all the parts that we need. Yeah, that's about it. Any questions?
I just want to mention something. So with electronics, if you're working on a sensor or a PCB, whatever thing you're working on, you are responsible for writing the test for those. Some of them have already been written in the last document. I can link that to you if you message me. But yeah, you just need to elaborate on that and explain why the way you're testing it ensures that that item is secure, is safe, will function as expected, and basically if it will do unit testing for that particular item.
Same goes for energy systems. You guys should fully understand, what it is that you're designing, and therefore any tests that you have to create, any remaining tests that you're missing from the previous documentation, and to fully expand on those. There's more stuff like a full design document, detailed components list, and testing procedure that will have to be outlined in the FDD. And that's part of what we expect to be in your 80% of the FDD complete. And when we say 80% complete, I'm going to use an analogy. I don't know if you guys play video games, but whenever Blizzard releases a game, it's pretty much complete, even though it's a beta. And that's how we expect our documentation to be performed. Your draft should be as best as possible, so it requires as little fixing. We can really focus on like just the really main major issues before we have to create the final version to submit to EHW.
But I have a question. Is there a word limit for the documentation? Like, do we have to, if each one of us starts writing documentation by him or herself, and then we go to compile the full document and we see it's like really big. So the question is there a word limit? Like, do we have to keep it short? Do we have to go into details?
That's a good question. Basically, the way we have it organized is that each originally was that kind of each subsystem had their own way of splitting up how the documentation was written, depending on like the sub projects that they had. And then, well, for energy systems, for example, I went in and I edited everybody's. I gave them 2 pages. For this document, because it's a full like design document, it's okay to go over, but I think it's important to distinguish, to not keep the design section too long, and then just try to keep as many things like put things in the appendix where appropriate.
Yeah, for sure. Okay, thank you.
I think. Sorry, go Ormel.
A big thing is we like to avoid repetition. So if you notice that like some parts of your design are they're common between, like, let's say for sensors, like your input output, those tests are like common, then you can just write like something about them and you don't have to mention them for each specific sensor. So try to avoid like repetition of like content, because it just coming from somebody that like will have to read engineering documentation, nobody wants to read the same thing again and again.
Yeah, and actually, I think it'd be important. I think it'd be good at our next leads meeting that we talk about what maybe the structure, and we could put together a rough outline for everyone's final demonstration document. In terms of what the expected, how it should look like, and examples of, oh, you would put this in the appendix, for example, to make it more clear. But like Ermel said, make it clear, and it should be legible and understanding. There's a formatting guide, and I'll show it to you right now. If you haven't been using it already, go to Teams, we go to Energy Systems. I know not all of you are in Energy Systems, but I think you all have access to this channel. You can click here, and we have a homepage. And on this homepage, there is a very nice, I think it's a nice formatting guide. It's over here, document formatting guide. And it kind of tells you roughly, it tells you what your what your document should do. I recommend you read this first section, and then how to format your stuff properly. And if you follow this, it'll make it easy for someone to follow along with your document.
Yeah, we'll issue out like another document explaining like the structure, what we expect, and the layout and stuff. But for the time being, there's a lot of like areas to cover. So I would recommend like everyone start like just coming up with some tests for their own like part. Even if it's just bullet points of like things you have to test out, that's fine because like it's something to start with, right? It'll make it easier down the line. Even if you have just us just cutting some things out and just like refactoring like the code, not the code, but like the writing, we could do that.
All right, yeah. So I think if there's no questions, any questions right now from the team, from the members on what the expectations are for the February 13th deadline?
I just had a quick question.
Yeah.
I'm just looking at the document for the FDD that they sent, and just like the previous one, I was under the impression that like the safety is one of the most important factors. So, you need to elaborate nicely on how your system is safe and keeps everyone around it safe. So I see that you've outlined testing procedures, but I think along with that, like obviously you would, like you said, 80% should be complete. So I think of that 80%, if we assume that 40% is testing, there should be 20 to 30% spent on safety as well, right?
Absolutely. So, I guess a focus on the safety sections. And I think the way we envisioned this was that 80% of it would actually, the remaining 20% would be safety. And it's kind of hard to write on safety if you don't fully understand the way the thing works. If you don't have a full picture of how the system works and the testing and stuff. And so the safety would be written between this 13th deadline and the final design document. But absolutely, if you want to write safety, I find it's hard to start with safety and fill everything else in. I'd recommend filling everything else in and then going into safety. Because
Something you guys should try is so like okay, this is actually like an air pressure connector, right? But like how do I know it's safe, right? You know it's safe based on these points of failure, right? So there's like a quick connect system, so that could fail easily if it on the other side. Okay, the material's made out of brass. Okay, is there an issue with that possibly? So like safety matters, but for this to start, look at the points of failure, and if you can show that you've covered all the points of failure, then you are safe because you've covered every single way it could fail, and you're going to test for that.
Right. Okay. Got it.
all right, are there any more questions? I'll take that as a no, and that you all understand what is expected of you. Obviously, in your individual sub-team meetings, you will go into more detail, but for now, we'll just move into the updates. I guess we can start with electronics.
Yeah. So in terms of sensors, Alex has figured out how to use the DC Hall current sensor. I think like, can each person from electronics just summarize their work and what they've done and through the past week and many major updates or minor updates that they have.
Sure, I can start. Hi, Jaden, Electronics. I've been working on mounts for. I'm actually 3D printing the mount for the Wanglor. It's one of the one of the sensors. You guys don't even know. It's for a distance sensor for measuring the gap height between things. I'm working on 3D printing one of the mounts just so we can test it right now. I just finished CADing and adding the CAD to the pod for the VN200 GPS, as well as what was the other one? Temperature sensor, temperature probe. Other than those, that's pretty much it. So it's just those two things.
Cool. Just following up with that, so Jaden needed some help determining the exact locations of some parts, and just to make sure that like the locations we chose are good. If possible, Max, if you could meet with just like some of the mech team leads and know for a fact that the heat sensors we're thinking of are the ones that we already planned for, it'd be good.
So just to make sure I understand, just double check that the places that we discussed before for where we want to place these sensors, I might as well do it for all of them again, right? Just double check that those placements they work with them, right?
Yeah, they work with them, and top of that, like for each sensor, each sensor is trying to measure something, right? So the temperature one trying to measure like hot stuff.
Mhm.
So make sure wherever we have it, it can actually measure like hot stuff.
Yeah, I can do that.
I think the specific reason that there was an issue that was brought up in the electronics meeting today was because the ProSense, there were two near each of the wheels, so there's four, right? And then a fifth one was near the center where the battery pack is, right? And the question was like, well, since the batteries and the motors for the wheels themselves already have temperature sensors built in, like what are those there for, and how can we mount them differently so that they're measuring something that we need? Like for example, I know that braking produces a lot of heat, a lot of friction going on. So where specifically can we have those temperature sensors mounted so that we're measuring something that we need?
Yeah, no, that makes sense. And I see Hamza's on the call. Just want to double check. I can talk to you offline, but I just want to double check that you're all right to discuss this with me, or should I be reaching out to someone else?
No, you can discuss it with me later.
Cool.
Sorry, just one thing, just so you know, when we were designing the brakes, we thought that they were going to be in vacuum, so there is a possibility that they might catch fire because the braking pads are made of Kevlar, and apparently that's flammable. So I was just like, when you're testing or or whatever, just have an eye on it.
You telling me our pod could be on fire, but not really in danger because it's like the braking pads, which are really far away from everything else.
Yeah, so we just
So what you're telling me is we have a feature where our
Bruh.
pod has flames.
Okay.
What I'm saying is that our pod will look the coolest.
Okay, but just on like a physics perspective, the reason your car's brakes work is because your brakes don't go on fire, so they can absorb the heat. If your brakes are on fire,
okay, this was the thing when we were designing the braking pads, because the constraint was that the material had to be softer than aluminium, so we couldn't use ceramic, which is usually used on braking pads. And ceramic is good because, as you said, it holds the heat. So what we decided to do is with like by consulting with a guy, he said that we can use Kevlar, but how that energy is going to dissipate is gonna disintegrate so the braking pad is gonna disintegrate as you go, and it might catch fire in the process.
Wait, actually that might be fine because in a vacuum you have no heat transfer because you have no airflow.
Yes.
Now we have an open air system.
Yeah.
So it would have cooling instead of no cooling.
So the thing, we thought it's not gonna catch fire in vacuum because in vacuum you don't have a lot of oxygen.
I see.
Yeah, but in air you do.
But we have to test it though, so I can't this is just something that might happen.
Okay, let's note that down then.
That's I think that would be important to bear in mind.
Yeah, so we can modify them and maybe replace them with ceramic if we don't have that constraint anymore.
Yeah. Hamza, keep that in mind, please.
Yes. I don't know. It's funny.
So I guess if brake temperature, whether it's on fire or not, is important to take account of, then we're probably going to want a temperature sensor right near those brakes just to make sure that we're not experiencing
like what else are you gonna do though, right? Like yes, look, your brakes are at the point of catching fire. What are you gonna do? Like stop faster?
You're going to stop the pod with the brakes that are currently combusting.
Yeah, exactly.
Actually, you could use the inverter. The inverter supports regenerative braking, so you could just
The inverter does indeed support regenerative braking.
Oh,
your battery doesn't though. Your battery might not.
Yeah, that was my main concern. It's like, could you just do it like that? And I don't think so. I don't think you could just like, hey, turn on the regenerative braking and it just does it.
Or what if you power it in reverse?
But that's what regenerative braking is. You're using the. What do you
Technically speaking, regenerative braking is when you don't give any power at all, and the motion of the motion already happening sends power back because that's how EM
Yeah,
works.
exactly. So it's
But if you power it the
like,
other way around, like
you
if you
mean
force
reverse.
current the other way around,
That's the thing. I don't know if the inverter supports doing that.
it does.
Well, like, as in, okay, if the motor does, I mean, the inverter can do that, then sure.
The motor can do that. The only issue then becomes is your motor directly connected to your wheels, or is there some sort of
Yeah,
like
it is.
like
So
okay, then you can't do that. Then the whatever the connecting shaft is gonna break if you try
Nah,
to
you're
do
gonna
that.
have a
Nope.
sick burnout.
okay, I this will be a discussion for another time, but I
Yeah.
think we're getting off track. I just want to focus on the updates. We can have this discussion at the next leads meeting, and I think actually it would be good that we have a meeting where we discuss the documentation for all electrical, and all electrical members are welcome. We could have maybe a work session on, because you'll definitely have questions when you're writing your documents. But we can go through like how to do that. That will be something that we do.
Yep, for sure. In terms of just like the sensor stuff, they're in progress. That's really it with the sensors. Some of them are closer more closer to be completed than others, but they're all in progress, generally speaking.
Sensor testing in progress. Okay, at least we have the sensor testing like already underway. That's good.
Oris, do you want to move on to the PCB side?
Yeah, for sure. So we had a discussion. I think everyone has a pretty solid idea of how the PCBs are gonna look like. We did the first stage of schematics. We might have to do some changes still, but hopefully we can start working with the footprint and like the physical layout this week. And yeah, maybe yeah, we'll see. So that's where we're at right now. Does the other PCB members have anything to add, or like, do you think it might take more time?
We really just have to like figure out how we want to configure it, whether it's like the Arduino coming down onto the PCB or the PCB sitting above the Arduino, which will sort of affect the layout, but not too much.
Yeah,
So,
but once we figure that out though, like it's just a matter of where do you place the pins.
yeah, it's placement, and like the toughest part for us is like getting the correct components and getting the models and the footprints for those exact components.
So just adding to that point, Anaki, you changed the power connectors. That's what I heard from Alex.
Yeah, so we didn't change the connector per se. So the PCB header for the power connector, the one that was originally selected, was designed to like it would come out parallel to the PCB. So it would be lying flat on the PCB, almost like how you'd plug into your laptop a USB port. But we changed it so it would be vertical. So like the PCB would be flat, and then your port is like this. It's kind of like sticking up, and then you can just plug it downwards.
Okay. Why did you do that though? Did you think it would be like better in terms of?
Yeah, it would be better in terms of placement because we wouldn't be able to fit. There's like I think like on each power strip there's about 15 different things, and those power strips, those low voltage power strips, are going to be put like somewhere in the pod, but you wouldn't. It would be difficult to plug it in sideways. It'd be easy. The way it's designed, like mechanically, would just be easier to have the power connector sitting upwards.
Okay. So can you just share them with us, or have you shared it with Alex?
I think I've gotten I didn't choose them, but I think Jasmine did, and she's sharing them with Alex.
Okay, thank you. Yeah.
Yeah. But in terms, sorry, go. Sorry, you go.
Okay, sure. I'm actually like researching like the connectors while listening to the. So for the current headers we're using right now, they have vertical versions, so we don't really need to do.
Yeah, exactly.
They have a vertical version.
Exactly. That was it. It was just switching to a vertical version. We didn't change the connector. We just like changed the PCB header that we have from the horizontal to the vertical version.
Okay.
Yeah.
on my by myself then, because it shouldn't be that hard. And then I'll send it to you, or I'll send it to you again.
Okay,
Yeah.
thank you.
Yeah, because the connector itself is the same, so you shouldn't have any problems there.
Yeah, I have a quick question about the power coming to the PCB. So I was just looking at like the 4-pin Molex that was on that document before. And I was just wondering if you guys know which, like how the pinout will be, like which ones will be 24 volts and which pins will be grounded.
Oh yeah, so out of that 4-pin Molex, I think what we were thinking, my idea, the way I thought about it was like we're just gonna have 2 pins just there, just for the simple fact that so that you don't plug the 24 volt into a 5 volt, but they're not even gonna be grounded. There's just not even gonna be pins in there.
Okay, so I was just wondering if that was like set in stone, if it was like written down somewhere where we could transfer it over to the schematics.
I think that would be a good idea and something that the low voltage power distribution team should talk to you about. I think Colin, you should meet with the low voltage team to talk about that.
Okay.
Because actually, like making sure that you have the right pinouts
Yeah.
is very important, so that you guys have the wires oriented correctly. I mean, in all honesty, we can also switch to 2 pins if that just makes it easier. We just have to be careful that we don't plug shit into the wrong port when we're actually assembling.
I mean, we can write on the PCB though.
Yeah, we can have a silk screen stuff.
Yeah, we could do that. It's just that because all the wires will be running to like one point, I can see it very possible that like whoever is, say someone's like redoing some work, and so they got to take that apart and then put it back, and they're not someone on the electronics or even electrical team, they would probably see all like try to put the right connectors in the right connectors, because that's how most things are designed. And if it's the same connector for 5 volts, the same connector for 24 volts,
so if you're worried about that, why don't you just change the type of connector? Like, is it a big issue?
Yeah, that's why I had Alex choose different types of connectors. But I think the solution we came up with was just to use the same connector, but 2-pin, 3-pin, and 4-pin.
Oh, I see.
If that's a problem, we can find a solution to that, just straight up using different connectors.
Yeah, it's not a problem. We just need to know which pins will be doing what. So. Okay.
Yeah.
Okay. So. Is that it? Yeah, Colin meeting with LV team to discuss. There will be some sort of standard. Okay, so I guess we'll go to software.
All right, hi. Okay, so let's so updates from last week to this week. So I picked up all the materials from Matt on Monday. Colin gave me the temperature sensor and the all of the materials in the box, essentially in a Mega Arduino, temperature sensor, board, resistors. So I got all that. I'm gonna program. So right now I'm gonna program the Odroid, just get it up and running, and then communications is working. Now that we have the Arduinos, we're gonna work on creating that network. So we're gonna try to see if we can get data from an Arduino, send it to the Odroid in that network, and then start creating channels that we can publish on. The controls team right now, they're working on, so we have separate projects. So one project is on the health monitor and the other project is on the state estimator. So yeah, so in other words, the health monitor will just be taking the data that's being published by the Arduinos. So let's say we set it to publish every 5 seconds or so. We'll just be updating the controller saying that, okay, if all the data is good, well, then we can just keep running. And then we have to figure out what's the appropriate combination of bad data that we can tolerate until we go to an emergency stop. All of that is really dependent on the parameters like every subsystem uses. So for instance, like braking, what are some parameters that you guys are expecting to have? Temperature parameters. So yeah, the level of so the decision making really depends on the parameters. I know that maybe you guys don't have them for now, but we'll just be putting in like arbitrary parameters just to make sure it responds well and it works. Infrastructure, I believe we have the lead here if he wishes to talk about data progress. Javad?
Sorry, just to clarify, you're taking data from the Arduinos to send to the Odroid or the controller?
Well, the Odroid houses the controller, right?
Oh, okay, I see.
Yeah, if Javad's here, if you want to talk about infrastructure for a little bit.
Well, for the infrastructure, we had also working two teams. We have a front-end module, and then we have a back-end module. The front-end module is working. We had a demo last week. We have few certain tweaks we need to make here and there, but we believe the front-end module is pretty good so far. The back-end module is also working, but the main issue we are having right now is integrating the back-end module with the front-end module. And that is what our focus is for the next week or two.
Yeah, thanks, Javad. So that's mainly what we're doing now. So today was it was a good day for us for me to go over with the team on what the materials that we have and how we're going to work with it. We do acknowledge it's kind of difficult to work together separately when one person has all the materials, that is myself. So I'm trying to make that process easier for my team. So what I'll be doing from next week is I will have like a camera set up that you can see overhead, and you can see my hands moving on the desk, and we can all just share screens together and see, okay, I'm going to plug this in. You can see what's on my laptop and you can see what I'm doing physically. So that way they can interact with me in a real case simulation. So that will make it much easier for the entire team to work together. So usually when we're in person, everyone can just come and help, set up, this Arduino or this wiring and stuff like that. So I'll just be streaming that, I'll just have a camera on a tripod overlooking my hands, and we'll just be streaming, the physical setup. So we can all just interact together and start working. So on one screen, we'll have someone just coding on VS Code. And then on the other screen, I'll just be doing the physical stuff. And once we start testing, everyone will be able to see, what's happening in real time and what the results are looking like. So that's essentially our workflow.
That sounds like a really good idea.
Yeah, it's probably the best way I can think of to truly simulate what it will be like working in person, and so everyone won't be too blinded about what's really going on. I think that's the best way we can do. That's the best we can do for now.
Yeah, that sounds awesome. Something you could add is VS Code has something called live share. So where the code will be replicated where like someone else around the world can be like typing it, but it'll be the exact same on your computer.
Yeah, so
so you could try using that maybe.
No, I already spoke to. We already have a plan with that. So what I'm intending to do is we have two shared screens. One screen will show me with a physical setup. So I'll have a camera on a tripod looking over my hands, and then on the other screen we will have a screen sharing VS Code with live share. So everyone can type code and do whatever they want, and everyone will be able to see who is typing what. And so when we run the code, we'll side by side, we'll be able to see actual results with the physical hardware. So that's what I'm looking to implement next week. So it should be more productive from next week.
I think that'll be really useful especially when you start to get to the integration of all the different electronics together and the software.
Yeah, so with my members' permission, once we start working and once we start implementing something, I'll try to record it, and then I'll send it to the general meeting. If you guys want to see a demo of what we're doing, I'll try to have, with their permission, I'll try to have that happen.
That'd be really cool. All right, energy systems. A lot has happened. So I'm not gonna give updates for all the small things because I think you guys, but I guess I'll take updates from June because I haven't really heard from him
Sure.
on his end.
I mean, like I think this week has just been a week of just people like going about doing their own things because for the most part the team members know what they're doing. I guess I'll start off with my end. Talk to Cardicade. We're going to finalize the connectors and whatnot for connecting the inverter to the rest of the like the Arduinos and sensors and stuff. The tentative plan is to go with like locking. I don't know if they're called Molex connectors, but they're like locking connectors with tabs, plastic tabs on them. The zip tie idea was a bit too sketch, so we're just going to go with like built-in tabs that you can just click in and plug it back out if you want. And
will you require PCBs for that?
No, it's just connector. They're just like SATA connectors on your computer or whatever.
Oh, okay.
Yeah, so that'll all just be in line, and then we can probably just zip tie the cables down to the base plate. Inverter housing, that's I had to make some changes on the 3D modeling front, but I'll send that out to or talk to my help makerspace. I don't know what they're doing with regards to 3D printing, if it's still open or if it's how it's going to work. And charging, the members worked on their SOP a little bit more, but I think for next week, I want to try to, like you mentioned previously, see if we can try to get started on the FDD and the testing side of things. Because I think because the SOP is just internal, right? More or less.
Yeah, the SOP is just internal to enforce safety, make sure everyone who actually is working with the batteries is doing it in a safe way.
Yeah, yeah. So the SOP is as done as can be because they, a lot of the members, Rayon excluded, don't have access to the ISDTQA charger or the batteries or whatnot. So it's as done as can be. They just went off and looked at YouTube videos and stuff. But we can start moving on to FDD for that. And high voltage battery team, we had a meeting with the some of the members from the braking system with regards to SolidWorks, like adding low voltage, adding the low voltage battery pack. I don't know what's happened on with them since then, but we need to figure out the wiring of or how we're going to connect all the different battery modules together to make the 6S2P configuration, and come up with like an optimal arrangement for that. Am I missing anybody? And then high voltage, I think you can cover.
Yeah, I think that's a good enough update. And I'll give a little bit for high voltage team. Looking batteries for 6S2P config. So big milestone. I think team. We got the demonstration actually. We were able to demonstrate how we're going to use the communication system within the high voltage battery for our I guess it's a waterfall style BMS. So demonstrate how to a working simulation of between Arduino BMS in battery. So actually, if Natasha is still here, yes, Natasha, if you could show your simulation. So what she did was she got a simulation working of 10 Arduinos together. So technically it's 9 Arduinos sending information to one Arduino, and it's all on the same line. I think it was just I2C, but it's a proof of concept. But it just shows that this can be done, and yeah, and actually there's a move from Arduino Nano to Arduino Micro as controller.
Yeah, did you want me to share my screen?
Yeah, if you could show everybody that demonstration, I think it'd be really cool.
Wait.
Yeah, so
Okay.
Natasha has been working with Tinkercad from the beginning. You can tell them about your project.
Yeah, so I'm working just to with the temperature sensors. So what I'm doing is I'm gonna what's it called? I'm getting the Arduinos to communicate to one master Arduino the different temperatures of the batteries. So this is just a simulation of all the Arduinos communicating to one master Arduino. So right here, so like every Arduino is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it just takes a while to initialize. There we go. And then, so Arduino number 1 is sending number 1. Arduino number 2 is sending 2. Arduino 3 is sending 3 to the one master Arduino. Yep.
Wow.
Yeah, so that's about it.
It's very cool.
Very nice. All right. Yeah. Yeah. So I think that concludes our all electrical meeting. Does anybody have any other questions? Anybody have anything else to say? All right. I'll take the silence as a no. So I take it that you all understand your responsibilities and the based on the expected timeline that we have. And good luck if you have, yeah, good luck working on whatever it is that you're working on, and we will be successful in putting this pod together. We have a very strong team.
And we'll especially be successful if we all grow up mullets.
Yes.
Exactly.
Next thing we gotta do.
Rocking
I think-
mullets.
It'll be really cool if everyone on the electrical team just rolls up with mullets. That's how we know they know these.
Yeah. And we'll all get matching shirts and matching uniforms.
Yeah, we should just go Canadian tuxedos mullets. I like it.
Yeah.
All right.
we
Have
intimidate
a good
everybody
day, guys.
Yep. Take care, guys.
Cheers.
See you. Thanks.
Enjoy the week, guys.
Thanks. Goodbye.